Welcome to My Safety Training Online, Evacuation Safety, June 2012. What you will learn from evacuation safety training: OSHA laws and regulations, excavation injury accident records, excavation safety definitions, the definition of soil classifications, discussion of protective systems, a discussion of sloping and its hazards/controls, emergency response procedures. 1926 CFR 29, Subpart P covers evacuation safety. It details that management must appoint a competent person. Soil evaluations must be done by a competent person. Daily inspections by a competent person. Shoring and sloping evaluations by a competent person. And most importantly, a stop work authority by a competent person. Part 2, Evacuation Safety Definitions. The definition of a competent person. Evacuation safety, when talking about a competent person, means one who is capable of identifying existing and predictable hazards in the surroundings or working conditions, which are unsanitary, hazardous, dangerous to employees, and who has the authorization to prompt corrective action to eliminate them. Part 3 of a competent person definition. Site safety briefings on evacuation safety must be given by the competent person. Daily excavation inspections should be done by the person, and more frequent if the conditions change, such as a freeze, a thaw, rain, the introduction of vibration, and the site is physically located in such a situation that it needs more frequent inspections. And most importantly, the competent person must have stop work authority. Part 3, Excavation Hazards. Did you know that the main excavation hazards start with surface encumbrances, which we will define what they are, utilities, access and egress issues. These issues also include adjacent structures, loose rock or soil, falls, and cave-ins. Included in these are vehicle traffic, falling loads, mobile equipment, hazardous atmosphere, and water accumulation. Let's define what a surface encumbrance entails. This includes adjacent structures, road and/or sidewalks, curbs and gutters, light poles, utilities, and mailboxes. Surface encumbrances need to be removed or supported, and examples of this would be fencing and piping, as well as any structures and materials that are nearby the excavation. Included excavation hazards are utilities such as electrical, gas, oil, and steam, communication, cable TV, water, and sewer. Remember to locate these prior to digging, certify that they are deactivated, protect, support, or remove them. The list of excavation safety hazards includes above-ground hazards, such as power lines which need to be de-energized, relocated, or isolated. Safety hazards include access-egress issues, such as poor housekeeping, which is the #1 cause of slips, trips, and falls. Debris needs to be cleared from all work areas. Those hazards need to be marked, such as barricades or covering the holes, and egress provided for the work crew inside the excavation situation. Access and egress criteria mean a 25-foot travel distance from any point in the excavation. The employer is required to provide ladders, ramps, and stairs to allow the work crew to exit the excavation. Traffic control is done by the competent person who sets up the site, first through evaluation of where the potential hazards are, and then devising methods of controlling those hazards. All personnel need to be equipped with traffic safety vets who are exposed to traffic safety issues. Remember, there is no work under loads which are operational, and operators must remain in the cab of all cranes in above-ground work near excavation. A competent person supervising the site will determine when these hazards are controlled. Mobile equipment at an excavation site requires setting up a warning system using barricades and hand signals, mechanical signals and stop logs, as well as grading away from the excavation. All this, of course, is also done under the supervision of a competent person. Hazardous atmospheres present one of the most prevalent excavation safety hazards, and testing at the 4-foot level is necessary if a leak in toxic is suspected by any of the work crew. Testing for hazardous atmospheres includes using the lower explosive limit whenever low oxygen is suspected, the presence of carbon monoxide, hydrogen sulfide, petroleum products, or other toxics which could invade the atmosphere. Excavation safety hazards when controlling hazardous gases mean displacing those hazardous gases and vapors with considerations for those that are heavier than air or lighter than air. This means exhausting or blowing in a volume of air needed to lower the concentrations to acceptable levels. Water hazards include protection from water accumulation, water removal using pumping devices, runoff protection. The competent person should consider temporarily shutting off all water lines anywhere near the excavation site. Controlling excavation hazards includes shoring and bracing, underpinning, and evaluation by a professional engineer. Rock and soil excavation safety hazards mean the protection of employees from these hazards using scaling, protective barriers, placing materials at least 2 feet from the edge, and no work on slopes above those workers in an excavation safety situation. Any surface 6 feet or more above the lower level shall be protected by walkways with a guardrail system, personal fall arrest systems, warning lines, and safety monitoring systems. Excavation safety hazards for cave-ins include protection from cave-ins requiring a systematic approach using soil classification, protective systems, constant inspections, and employee training. We'll discuss each of these in depth. Part 4, Soil Classifications and Protective Systems. Protective systems are required unless the excavation is in a stable rock situation, the excavation is less than 5 feet, 4 feet in some states, and examination by a competent person determines no potential for cave-ins. Protective systems include sloping and benching, shoring, sheet piling, and shielding. An example of this would be trench boxes, and using a professional engineer to design if it is deeper than 20 feet. Here we can see the 3 types of sloping. You have type A, which is 3 to 4 to 1, 3/4 to 1. Type B, which is 1 to 1, and type C, which is 1.5 to 1. The soil types are 3 types. Type A, which is shown in the first diagram. Type B, which is cohesive soil, and type C. Excavation safety ensuring is based on OSHA appendixes and is based on the manufacturer data as well as designed by a professional engineer. Shoring includes Appendix C of the OSHA regulations, which requires a soil classification by the competent person. It is based on the depth and width of the trench, and the competent person should consult tables for specifications on cross bracing, wales, and uprights. The competent person should consult Appendix D when discussing OSHA regulations on soil classification, the depth and width of the trench, tables for specifications on hydraulic cylinders, wales, and uprights. Here we can see the various types of trench boxes. Figure 3 shows the screw jack types of trench boxes, and Figure 4 shows various types of trench shields. Installing protective systems need to be done in the correct manner. Systems need to be securely connected when they are installed. Employees need to be kept clear of the area under the shields during installation. They need to be installed to prevent movement, and they must protect employees while entering and exiting the excavation. Protective systems require the removal. When they require the removal of them, employees must be kept clear of the area under the shields during the removal. The shoring must be removed from the bottom up and slowly, and the backfill will be done after the removal. Daily inspections of all competent persons of excavations are at the start of the shift if needed, following a rainstorm and or other hazard increasing event, any possible cave-in that may have happened, a protective system failure, water accumulation, evidence of hazardous atmospheres, and of course have the authority to remove workers from the excavation site. Part 5. Excavation Safety Rescue Procedures. Here we can see an excavation safety rescue that actually happened. You can see the work crews have the ability to easily access the site, the protective systems that are in place, the length and width of the excavation, and specific procedures which have been established. Remember, do your initial analysis of your situation. What type of incident can happen here? Would it be a cave-in, a flood, a medical situation, a fire or a spill? What type of injuries can happen here? List the number and the type of injuries which would be expected. Who would be the missing personnel? Names, address, phone numbers. What type of chemical or sewage exposure? What safety measures are needed for excavation for the rescuers? Remember to notify field personnel, the health and safety officer, who is often the emergency coordinator. Notify the fire department, the police department, emergency medical services, and the hospital. Remember, don't be a hockey puck like this guy. First stabilize your cave-in, then control the flooding. Ask if there are any hazardous atmospheres. If yes, first ventilate. Then use supplied cylinder breathing apparatus. Provide a safety harness and a line, and a basket stretcher. The best rescue is one that never happened. Be prepared and practice your rescue frequently. Excavation Safety Summary. Protective systems include sloping and benching, shoring, sheet piling, and shielding, such as trench boxes. They need to be designed by a professional engineer if deeper than 20 feet. They need to be planned and practiced frequently, including how to notify emergency personnel, who would be affected, what hazardous conditions might exist. Safety protective systems on evacuations less than 5 feet are required, and 4 feet in some states. Thanks for participating.